In this lesson, we're going to be solving this problem. This problem is under a thermal expansion. The problem it reads as follows. A steel plate with the dimensions 100 cm by 50 cm by 22 cm is heated from 25 degrees Celsius to 209 degrees Celsius in a furnace. Calculate the expansion in the side of a plate of a length 50 cm. Calculate the area, the given base specific dimension here for the area, this one. So, and then the increase in volume, that means they are looking for an increase in volume. The area in this dimension at this side, that means they are looking for the total area. Here the percentage that it seems they are looking for a percentage increase of volume, that means they are looking for, here you only need a change in volume divided by the original volume times 100%. That means this, you have to calculate this. You already have here the dimensions for the initial volume. So without wasting any time, let us get into it. Here, let us first calculate the initial volume. It is 100 centimeter by 50 centimeter by 22 centimeter. This gives 110,000 centimeter cube. That's the initial volume. Then let us roughly calculate this initial area that they gave us here. We'd say initial area here, it is 100 centimeter by 50 centimeter. This is gonna give us 5,000 centimeter squared. That's this area. Let us calculate the change in length in this question number 1. The change in length, change in length is equal to the coefficients of linear expansion times the initial length times the change in temperature. It is like this. The coefficients of linear expansion, it is this one, 18 times 10 to exponent negative 6, it is 50. Then the change in temperature, it is 290 minus 25. This one, this is temperature. It's temperature 2. This, it is temperature 1. The answer here is gonna be 0.238 centimeter. That is the change in length. Now they say you must calculate the area of the 100 centimeter by 50 centimeter side at 290 degrees Celsius. That means we must first calculate the change in area. But first we have to calculate the coefficients of the area expansion. The coefficients of the area expansion, it is 2 times of the linear coefficients. Then that is 2, then you times with the linear coefficients, which is 18 times 10 to exponent negative 6, like this. Then here you will get the coefficients of area expansion to be 36 times 10 to exponent negative 6 per degrees Celsius. That is the coefficients of area expansion. Now we've got the coefficients of area expansion. Now calculate the change in area. It's gonna be the change in area, then the coefficients of the area expansion, the initial area times the change in temperature. Then here the coefficients of area expansion, we've got it now here. It is 36 times 10 to exponent negative 6. Then the initial area, we've calculated it here. Here it is this for this dimension, because here they are given this dimension, this one. Then we put this dimension here. We put that initial area here. It is 5,000. Then the change in temperature, 290 minus 25. Then this is gonna give 47.7 centimeter squared, like this. That is a change in area. Now you have to calculate the total area in this temperature. this temperature. That means you'll say a total area is equal to initial area plus the change in area, like this. Then from here, initial area, we said it is 5,000. It is 5,000 plus the change in area that we got it now here. It is 47.7. This it's gonna give us the 5047.7 centimeter squared. That is a total area. That's a total area that they are looking for in that. Now question number 3. This is C. They are looking the increase in volume. That means they are looking for the change in volume. But before you calculate the change in volume, you have to find the coefficients for a volume expansion. To find the coefficients for volume expansion, you simply say coefficients for volume expansion is 3 times of the linear expansion coefficients. This is 3. Then you put the coefficients for linear expansion. It is 18 times 10 to exponent negative 6. Then this is gonna give the coefficients of volume expansion to be 54 times 10 to negative 6 per degree Celsius, like this. Now we have to calculate the change in volume. The change in volume is equal to the coefficients for a volume expansion, then the initial volume times the change in temperature. This coefficient, we just find it now here. It is 54 times 10 to exponent negative 6, like this. Then the initial volume, we found it here to be 110. Found it here, it is 110,000 centimeter cube. Then it is 110. Then the change in temperature, it is 290 minus 25. The change in volume to be 1574.1 centimeter cube, like this. Now we've found the answer for this question C. Now let us go to question D. Here they are looking for the percentage increase in volume. So we would say percentage increase is equal to a change in volume divided by the initial volume times 100%. That's how you calculate this percentage increase in volume. Then it is a change in volume. This one, we've got it now. It is 1547.1 divided by the initial volume. It's 110,000, like this. Then times this 100%. Then what we get here, we get the percentage increase in volume to be 1.431%. That's what the last question is looking for.